The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Hello and welcome back to the Ben Heck Show. Way back in one of the very first episodes of the Ben Heck Show, we attempted to build an automatic can crusher, but we didn't quite succeed. I've always wanted to revisit that project, and now, with help from the Element 14 community, we've got that chance. We asked our viewers to come up with ways that they would solve the automatic can crusher problem, and they submitted the entries to the Element 14 community. We've taken some of those ideas and we're going to apply them to a new can crusher build in this episode. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
After looking over all the suggestions on the Element 14 community, we narrowed down on some basic concepts that we think we're going to use for our can crusher. Let me take you through it. We like the pneumatic can crusher, although it's more than we're going to build for this episode, and the fact that it had an easy to load hopper. The cans are up here, and pretty much no matter how you throw them in, they always end up and down, which makes them really easy to load and consistent. However, we like the idea of compressing a can sideways. And we also saw videos where people were using bike wheels and motors to run a piston to crush cans. The problem with that is that you have to load the cans sideways, which is actually, the cans don't want to end up sideways. If anything, they want to end up and down. So we thought about making a rotating drum where the can comes into the drum, then it rotates 90 degrees, and then it gets crushed, and then it gets dropped into the bin. The problem with that is we're not sure that we can do this piston action with a small motor. Again, we're trying to make this as simple as possible and as small as possible and without using air compressors or pneumatics. The solution I'd like to try is this. It's kind of a combination of several of these things. We have a large wheel, probably about 20 or 22 inches, and that acts as a way to give us a lot of torque, because in our original can crusher episode, we realized when you use a can crusher, you've got about a 22-inch gear, and you need a 3-to-1 gear ratio to drive that. So if we make a wheel this large and then we actuate it with a 3-to-1 ratio off a large stepper motor, it should have enough force. And I'd like to do it with one motor, and here's my plan. The can will drop in, then we have an inner portion which will rotate 20 degrees, and it will engage a rack and pinion crush here. And then what will happen is it'll continue to rotate another 180 degrees, and as it does, as it rotates, the rotational effect will cause this to crush in on the can. Then when it comes back over, the can will fall out into the bin and it'll be ready for the next load. The advantage of this is we get a side crushing action like this, and we're able to load the can in from the top like that, and we should be able to do it with just one motor. Let me show you my computer drawing of this, and then we'll build a mock-up to see if it's feasible. Let's take a look at the design I came up with. So here's the larger wheel I talked about. It's about 22 inches. And the can would insert here at the top. Then we have a staggered cam here that will rotate with the can. So it would do something like this. When the can is loaded, it obviously clears the crushing mechanism, so it has room right here where the mouse is moving. Then it rotates 20 degrees, like that, at which time the cam engages. So further movements move everything. It moves the can and the rack and pinion crusher. And once it's gone 180 degrees, the rack and pinion on the crusher will cause the crusher to move in 4 inches, which is about the distance we need to crush a can, and the can should be crushed. So the total movement will be 200 degrees, 180 of which involve the can crusher. And then it will reverse. The can should fall out in this direction. Then it goes back up to the top, and then the cam resets, allowing the can allowing the can opening to be vertical, allowing more of them to come in here. I want to make sure this theory at least has some chance of working, so I'm going to start by laser cutting some foam jigs. Here's the mock-up that I made with the laser. It has a rack and pinion to drive the crushing element. This is the pinion, this is the rack. Normally the pinion will rotate, causing the rack to move back and forth. That's a good way to make linear movement. In this case though, the rack is attached to sliders on the main wheel here, and this is what rotates. So as the wheel rotates, moving the can, the rack moves along the pinion, causing this to move in. See how that comes in like that? So what'll happen in a crush sequence, the gear isn't super tight because there is some slop. This material tends to burn and contract. The can will be loaded. Then the outer gear will rotate 20 degrees to bring the can into the crush zone. And it'll be right about there. And then there'll be a plate here that the can is crushed against. Once it's moved 180 degrees, the can will be crushed. Then it will come back out. The crushed can will be able to fall out. And then we reset for the next can. So it looks like my rotating rack and pinion can work. The next step will be to make each of the pieces one at a time. It's going to take a lot of material, so I want to make sure that I do it right. So I'm going to make the middle, and then I'm going to make the next outer piece, and then the outer piece after that. This is what I'm calling the crush core, even though no crushing occurs in it. This is the part that actually will get actuated by the main gear rotating and crushing the can. So the rack and pinion will attach here. Now earlier you saw the gear that we had a foam mock-up of, so I'm making them out of Sintra here, and they're 1/2 inch thick. And what I'm looking at now is the tolerances we need. There needs to be a immobile gear inside of this, and there's actually going to be a gear on either side as well. So I just have to make sure that whatever rotates inside of this has enough tolerance that it will rotate smoothly. This is 0.02 inches gap. It has a little bit of movement there, but keep in mind there's gonna be like 4 of these stacked on top of each other, actually more like 6. So all the tolerances aggregated together should be a little tighter than this. So now that I have a good tolerance here, I'm going to cut these pieces so I can build them inside of the core, because I actually have to build it in sequence. So I'll put this together, then I'll put these cores in with the gear on the back. Then I'll put this together, then I'll put the inner pieces in, then I'll bolt those together. Yeah, so I had to make sure the tolerances are right because I have to build this all in one piece. Here are the core pieces. I'm going to put them together and then add the gears. I have quite a few screw holes in all of these pieces so I can stagger the screws and put it all together, because if you needed one screw that was as long as all of this, I mean that would be quite a long screw. I don't think I even have screws that long. That'd be like what, 3 inches? Actually I might have screws that long. So anyway, these are going to go together like this in a core. They'll fit inside the crush core, which sounds like a Nintendo DS game. And then the gears will affix to the outside of that. Son, I want you to take this crush core in the center of Pandora and blow up the planet. I don't care about those blue aliens. Kill them all with the crush core. Or maybe it's like, dun, 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 dun. The crush core works out your core and your abs and your gluteman muscles. Is that even a word?
Glutes.
I like the crush core. It's got a nice solid feel to it. Now it's time for a tech timeout. One question we get asked a lot on the Ben Heck Show is, how do I get started with electronics? Here are some basic tips. Pick a simple project that you can manage. Don't dive in too deep. Don't hand wire your own computer, but perhaps make a simple blinking light or a smoke detector or a object detector for your car door. Simple stuff like that. Pick something small that you can manage. Then buy tools and parts as you need them. When you need to desolder something, that's when you get the desoldering iron. Or when you need to use a magnifying glass or helping hands, that's when you buy them. It's a good way to avoid buying more tools than you need, and then you can also save money that way. It takes longer, but again, you're getting into it. You're taking it one step at a time. Learn through problems. That's the best way to learn. I mean, that's how I learned most everything. Work on your project, and then when you get stumped, go online, use the community, use Google, and do research, because chances are someone else has already figured it out for you. So you can just find the answers online and then apply it to what you're doing. And then you can take it to the next step. That's a big part of learning as well. And of course, have a project goal in mind. Again, pick something that you want to do and have an end point. Like, I want to build this, and then when it's done, I wanted to do X, Y, and Z. So having a clear project goal in mind will help you keep on focus and on target and help you finish. Because if you're just building whatever, you can get distracted and never finish it. So those are my basic tips for getting started with electronics. This looks like a grenade from Final Fantasy. And then like a bunch of numbers would fly off of Allison because I'm attacking Allison for major damage. So the reason I had to make this before I could make this is because it fits inside of this like that. Then the cam goes around it. Then this. I think that's how it works. Oh wait, I think it's actually like, looks like some sort of prop from a Dan Brown movie. That's what it looks like. Yeah. So what actually happens is the gear, as you saw in the demo, the gear doesn't move. This thing moves around the gear, which, oh yeah, I guess I can just, come on. Oh, now it doesn't want to come apart. There we go. So the thing, I think it's about like this. The main rotational piece actually pushes this lock here. So it makes it rotate like that, but this actually stays in place. So there'll be another piece holding this in place. And then this is attached to, see that? So actually if I, see how that goes back and forth? And it'll slide on sliders just like it did before. Sliders, your favorite TV show. Yeah, I just said that. So this is kind of the opposite of how it works. Normally the gear doesn't move and this whole piece does, but yeah. So as this rotates, the can will get crushed here. That's one of the reasons why this is as wide as it is. It's 3 inches wide, which is, well, wide enough for not just a can, but a crushed can, because, oh, of course it leaks. The can's diameter is greater when it's crushed. Yeah, so I'm gonna finish putting this together, and we'll move on to the next step after I wash my hands. I have to screw these together in a certain fashion. I have to put enough screws in it to keep it stable and steady, but I also have to leave mounting screws. So I'm gonna put 2 in this way and 2 in the other way, and then a few extras. I also put screws in here. Hopefully that will work. Although I just realized I can't countersink these with the gear in place, so I've actually got to remove the gear. But I can countersink these before I do that, so. Yeah, it's kind of like a puzzle. Not just taking a puzzle apart, it's like putting a puzzle together the right way. I guess there's probably puzzles like that too. There we go. The belittle dome. All right, I'm going to do another test before I proceed. So, can drops in here, then this is pushed, so then the can is here. So remember, this gear doesn't move. So this rotates around, and this isn't going to rotate the full 180 degrees because these slots need to be changed. Anyway, it comes all the way around, and by the time it comes 180 degrees, see how this is compressed? So in theory, that should crush the can, and then it opens back up and is ready for the next can. So what we're gonna have to do is the mount for this. There's gonna be something that actuates this, so that'll actually be a big flywheel that we talked about. And then there'll actually be a mount here holding the gears in place, so it'll be kind of like this, almost like a saw blade. But that stays put, and then this rotates around it. So just like this. And then there's going to be one of these on either side. Then this slot here is so we can have a piece of plastic for compression. And then it's going to compress the can around the outer rim that we haven't made yet that actuates this. But we should be able to make that with less plastic because we just have to be as high as this. So it comes up here and here. But I think what I'll do next is actually make these pieces out of Sintra so we can actually bolt them in place. It's always good, at least what I like to do is build it one piece at a time, like design one part of it and then test it, then design the next part. because building something in reality is always better than doing it on paper or the computer. Now that I see that this works, I'm confident to continue to the next part. I've cut the side pieces now. I have to put this together first before I can put these on, but yeah, so kind of see how these are going to go. See that? This is going to get pulled down over it, and this is what's actually going to crush the can. I hope this thing works. It's a little sticky right there. That's okay, we can work it out. We can work it out. We can work it out. Try to see it my way. Time will tell if this project's gonna work. This is the crush zone. Don't stick your hand there, or you won't have a hand. Well, you'll have one less hand. Unless you already have a hand missing, then you'll have 0. Little hand. I'm afraid that you are forever banned from editing the Game of Thrones wiki. Around the crush core, we need something to actually hold the can and actuate the staging inside of the crush core. And that's why I made this. Now this is just a temporary rig. Once we know that it works, I will rebuild it to hold the can. So unfortunately, it uses up expensive plastic. So we have an indentation on it here, which is 1/8 of an inch, and that will allow these ball bearings to sit in between them. So the ball bearings will surround the unit in the center. Okay, so when these are in place, well, this will be here too, but just to test it now. So this whole thing rotates on the ball bearings. The actual gearing will be on this ring. It will move 20 degrees to move the can into place, and then it will engage the inner crush core to move the rack and pinion arm to actually crush the can. All right. So I'll make sure that all the ball bearings are in place and put this inner core together. To keep the center core from falling out, or rather to keep the outer core in place, I've put these things that look very much like brake pads on it, and they actually have ball bearings as well. So there's ball bearings around the perimeter and on these surfaces as well. So we'll also put a pair of these on this side. Then it will be completely enclosed. I picked up a slug and I tickled it. I've got more of it together, so the demonstration will make more sense. So the can comes in like this, boop, and that's why we have this rotated 20 degrees, so the can can go straight into the hopper. And there'll be a plate here and a pusher, but you know, just imagine it for now. So the can comes in, and then once it does, this rotates 20 degrees, and then it locks in place to where the crusher is. So then the next can will be blocked from going in as well. So now the can's ready to be crushed. And remember, this gear doesn't move, everything rotates around it. And then this will have either a belt or a gear actuating it. So this wheel here is actually where the torque is applied. I'm just gonna do it by hand. So it rotates, and as it rotates, the gear stays in place, causing the rack and pinion to rotate around it. Then it rotates after the can load 180 degrees to that point. Okay, so the can should be crushed at that point. If you take a look here, there'll be a 1/2 inch plate, and there's your crushed can. Okay. Okay, at that point, it basically reverses. So see how that's in place? Now that this goes over, locks again, then starts, well, basically just reverses it. This is really hard to do without, having the gear locked, but whatever. So about halfway along the way, the can should just fall out into gravity. So your garbage can would be actually right about here, not here. Oh, I'm sorry, your recycle can. Yeah, okay, so then it returns to 20 degrees, 0 degrees, ready for another can. We should take a pinball break. That's all the time we have for today. So we've built the crush core. Next week, we're going to add some gears and a motor to give it the torque it needs to crush the cans, and also put in some control electronics so it knows what it's doing. We'll see you then. Find instructions online, find instructions. Ugh. Well, here are some 4 basic tips. Here are some 4, that's not right. If you laugh at anything, if you go someplace really sad, that's the irony. It's Twilight Zone 101. Your mom's going down. She's yelling timber. She can't get up. She's gonna die. Maybe it could be like a Mary Kate and Ashley direct-to-TV movie about like them in high school, like crushing on guys. Or a fitness video. It could be many things. I've always wanted to revisit this project, and now would help for the element.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.